Have you ever wired a brand new 4 to 20 milliamp field transmitter to a PLC input card, verified every terminal screw is tight, yet your control system reads exactly 0 milliamps? What causes this silent loop failure? The answer comes down to electrical rolls. In every 4 to 20 milliamp current loop, you must have three fundamental elements: exactly one power source, one current regulator, and one measurement load. If you have zero power supplies, no current flows. If you have two power supplies, they fight each other and can destroy your PLC input card. Let's define sourcing. A sourcing device is active. It contains an internal power supply and pushes electrical current out of its positive terminal into the external wiring. When a PLC card is configured as sourcing, it provides the loop's 24-volt power directly from its own terminals. In contrast, a syncing device is passive. It generates zero voltage on its own. Instead, current enters its positive terminal from an outside source, passes through its internal circuitry, and sinks out of its negative terminal into common ground. A passive PLC card is simply a measurement load waiting for external current. Field instruments follow this exact rule. Standard two-wire transmitters are passive loop power devices. They share power and signal over the same two copper wires, regulating current while sinking power from the loop. Four-wire transmitters have their own separate mains power, allowing them to actively source loop current. Quick field challenge. You are connecting a four-wire magnetic flow meter powered by 230 volts AC to your PLC. How must you configure the PLC analog input channel? Syncing or sourcing? Take 3 seconds to lock in your answer. The correct answer is syncing. If you configured the PLC as sourcing, you create the double sourcing trap. Both the transmitter and the PLC card output 24 volts on the same wire. Because there is zero voltage differential, no current flows, or a reverse voltage spike blows the card's internal input fuse. Let's look inside the PLC analog input channel to see the invisible mechanism. Current flows through a precision 250 ohm metal film resistor, converting 4 to 20 milliamps into a clean 1 to 5 volt drop. An optocoupler LED then converts this voltage into light, providing complete electrical isolation from noisy field ground loops. When troubleshooting in the field with a loop calibrator, this distinction is critical. In source mode, the calibrator acts as an active power supply to test passive PLC cards. In simulate mode, it acts as a passive two-wire transmitter, syncing current from an active PLC channel. Here is your universal cheat sheet. Passive two-wire transmitter connects to an active sourcing card. Active four-wire transmitter connects to a passive syncing card. And if both are passive, you simply insert an external 24-volt power supply in series. Remember the golden rule: every loop must have exactly one power source. If this video cleared up 4 to 20 milliamp loop wiring for you, hit like and subscribe for more industrial automation engineering breakdowns. See you in the next lesson.